Okay, this is lesson 11.3, simplifying rational expressions. Example 1, find excluded values. So in a normal fraction, we know that we can't have 0 as the denominator because you're not allowed to divide a number by 0. Otherwise, it is undefined. So in these problems, we're going to state the excluded values for each rational expression, meaning what values can the denominator not be that would make it into 0. So if on most of these questions, you might need to factor the denominator first. Sometimes it's already factored for you, which is nice. But on all of these 4 examples, we need to factor first and then set the denominator equal to 0. So question letter A, negative 8 divided by r squared minus 36. So we should know from chapter 8 that r squared minus 36 is a difference of squares. So you can factor that into r minus 6 and r plus 6. So in the first group, the r minus 6 part, the r, if it was equal to a 6, then that would be 6 minus 6, which turns that into 0. And in the other set, you have r plus 6. So if r was a negative 6 in that group, negative 6 plus 6 is 0. So the excluded values for this problem is r could be anything else except for a positive 6 and a negative 6. Likewise, down below, 1a is very similar. You have 5x over x squared minus 81. X squared minus 81 is a difference of squares again, so that factors into x plus 9 and x minus 9. So the 2 excluded values for that one are a positive 9 and a negative 9. Letter B, so now we have a trinomial in the denominator. So this goes back to chapter 8 again. Little above that, you can see the X model chart that we did. Find factors of C that add up to B. So I need to think 2 numbers that multiply to negative 5, and they add up to a positive 4, and those are 5 and negative 1. So the denominator factors into n minus 1 and n plus 5. So the 2 numbers for the excluded values, n can be anything at once except for a positive 1 and a negative 5. 1b, down below, we have another trinomial, a squared plus 6a plus 8. So I need to think 2 numbers that multiply to 8, but they also add to 6, which are 4 and 2. So that factors into a plus 4 and a plus 2, and the values that a cannot be, otherwise that denominator would be 0, is a negative 4 and a negative 2. Okay, moving on here, simplifying expressions. So this goes back actually to chapter 7 for the exponent property rules. So we have negative 3x squared times 4x to the 5th all over 9x to the 6th. So we can combine the numerator, so we can multiply the coefficients, negative 3 and a positive 4, to make negative 12. And then your exponents on x can be added together. So 2 plus 5 gives you x to the 7th. Then if you put that over 9x to the 6th, now we have the quotient rule. So we can divide or simplify the fraction negative 12 ninths, which reduces down to a negative 4 thirds. And for the quotient rule, think about, you can either subtract the exponents or know that you have 7 x's on the top and 6 on the bottom. So if you cross 1 from the top with 1 from the bottom, you're going to get 1 left, and it's at the top. So this letter is letter D for the answer. The second one, 16 divided by 8 for the coefficient gives you a 2 in the numerator. You have more c's in the denominator than you do up top, so you're going to have 1 left underneath, so that's 1 c at the bottom. And you have 4 b's at the top and only 1 b down below, which means you have 3 b's that remain up at the numerator. So that answer is letter F, 2b cubed all over c. Now, this is very important, and you'll see this on the next slide example. So every time you do this, a kitten dies. So don't do this and save the kittens. So you can't cross off the x squareds like it shows you in the example. The reason why is you can only cross off factors, and this isn't in a group of parentheses to cross it off. This is separated with adding and subtracting. In another example, it would be subtracting. So don't just cross away x squared. So think you got to factor everything first, and then you can cross things away. So this is the last 3 examples I'm going to talk through. Example 4, simplifying rational expressions. And we also need to state the excluded values of r. So the first thing you want to do, over there I have a little checklist. Number 1 is factor everything that you can. So sometimes you can factor by using the greatest common factor, like that numerator there. 2r plus 18 has a GCF of 2, so you can bring out the 2, and r plus 9 is left over, so it's kind of like reverse distributive property. And the denominator, that trinomial, I need 2 numbers that multiply to a negative 9 but add to an 8, so that factors into r minus 1 and r plus 9. Now step 2 is you want to figure out what the bottom excluded values are. So r cannot be a 1 or a negative 9 down there. And then third, you want to simplify. So you can cross off, in this case, the r plus 9 factors because they're grouped with parentheses, so those go away. So I kind of say this is like a fruit ninja. You can slice those away. Hiya, hiya. The study tip off to the left says that the excluded values are from the original rather than the simplified expression, which means my final simplified answer to this is 2 over r minus 1 there in the pink box. But before I crossed off the r plus 9s, I had to list my excluded values from that blue answer. So it was 1 and negative 9. So the last 2 examples, 4a, n plus 3 at the top, I can't do anything with that. The trinomial at the bottom you can factor. So 2 numbers that multiply to 21 that add to 10. So that factors into n plus 7 and n plus 3. And here you can cross away the n plus 3s because those are like factors. So you only have a 1 left at the top because everything else is gone, and the n plus 7 underneath. And again, the excluded values come from the pink original problem when it's all factored before you cancel anything out. So n cannot be a negative 3 or a negative 7 down there. Otherwise, that makes it 0. And the last problem, the top is a trinomial, so think factors of negative 10 that add up to a 9, and that is y minus 1 and y plus 10. And then the denominator, you can factor by using the greatest common factor, bring out a 2, and the y plus 10 is left over. Here at the bottom, you only have 1 excluded factor or number, which is only a negative 10. So in this case, you didn't have 2 like some of the other examples. And the y plus 10s can divide out. So the only thing you have as your answer is y minus 1 all over 2.